Find the volume of the solid obtained by rotating about the line x equals -2, the region bounded by y equals x and y equals x square. So first we want to graph these two curves. Okay, so here is the vertical axis y and horizontal axis x. Y equals x is the identity line passing through origins. So this is y equals x and y equals x square. So y equals x square, just a parabola. So y equals x square. So this is the region bounded by these two curves. Okay, these two curves, and this is origin 0. And how about here? What is this? X and x square are equal when x equals 1, and this one is also y equals x, so this is also 1. So we are revolving, rotating this shaded region about the line x equals -2. Okay, so let's draw that line, -1, -2. Okay, so here's the line x equals -2, and we want to revolve this about this. Okay, I want to use the disc washer method. It will be washer because we have so for washer or disc washer method, we want to take a slice perpendicular to the axis of rotation. So we want to rotate about this line, so take a slice perpendicular to this, so like here. Okay, this is the slice, and it has small width of, this is the small width that will be on vertical axis, so delta y, small width on y axis, so delta y. That suggests our volume formula will be in terms of y. Okay, because the width, the small width is on y axis, okay, on vertical axis, so delta y, so y. And the area of washer, and this small slice can be taken anywhere, so from here to here, so 0 to 1. So this will be the volume formula that we will be using later. So we need to find the area of washer when we rotate this slice, sample slice, about this line. Okay, let me erase this part. Now if we revolve, rotate about this, so we get a hollow disc washer. That's the outer part, and this is the inner part. So let me draw smaller washer here, and this sample slice is here, and the axis of rotation is x equals -2. Okay, okay, now to find the area of this washer, okay, this is the sample slice from here. Let me use a different color. This is the sample slice here. Now to find the area of this washer, we need to know the outer radius and inner radius. Okay, the outer radius here to here, all the way, outer radius, and we need to know this is r, and inner radius lowercase r. Okay, so outer radius all the way -2 to outer part. Okay, -2 to 0, this is x equals 0, y axis is same as x equals 0. So from here to here, that's always 2. This distance is always 2. Okay, this distance is always 2, and we have to go more. 2 from here to the curve, this is always x direction. Okay, x direction, and this is given by the y equals x square curve. By the way, since our integration will be in terms of y, we need to convert, we need to change these curves as a function of y. So we need to write x equals function of y. So y equals x is same as x equals y. So let me rewrite this curve. This is easy, just x equals y, the identity. We need to do the same for y equals x squared. We need to write x equals what? If we take a square root, then x equals root y. So this curve is same as x equals root y. Plus minus, we are working on positive, so this is positive y. Okay, so we are trying to determine the outer radius from x equals -2 all the way to outer curve. That's the uppercase R. From this axis of rotation to y-axis, that's 2 plus something. So we want to go from here to all the way. This direction, horizontal direction, is x, and this is the curve given by root y. So here to here is x, which is given by root y. So 2, this is 2, and from outer part, that's the x direction, which is given by root y. So the outer radius is 2 plus root y. Let's go for inner. Okay, for inner radius, again from axis of rotation to y-axis, that's 2. Now we have to go from here to here. Okay, we need to find this distance. Okay, here to inside. Inside means on this curve, identity line. So this is x, which is given by y. So 2 plus y. That's 2 plus y. Okay. Now once we have the outer radius and inner radius, we can find the area of this washer and plug in there and integrate, you get the volume. Okay, then area of the washer is given by, not x, it will be in terms of y. Y or just a pi r square, area of circle gives everything, minus hollow inside, so we need to subtract pi r square, which is, we can factor pi out. R square, 2 plus root y squared, 2 plus root y squared, minus, I factor pi out, r square lowercase r, 2 plus y quantity squared. Let's simplify. Pi 2 plus root y squared, multiply 2 plus root y by itself, and you will get 4 plus 4 root y plus y, minus multiply 2 plus y by itself, because 2 plus y is squared. That will be 4 plus 4y plus y squared, but there is a negative sign, so 4 minus 4y minus y squared. We might be able to combine, simplify. So 4 cancel, plus y and minus 4y, negative 3y. Okay, pi outside, 4 root y, these two can be combined, so negative 3y minus y squared. That's the area of the washer. Okay, now the volume is given by 0 to 1, the area of the washer, so we can pull pi outside. In fact, 4 root y minus 3y minus y squared with respect to y. Okay, let's evaluate this definite integral. Pi outside, I'm going to integrate term by term and evaluate from 0 to 1. So 4 is 4 root y raised to 1/2, integrate. So y raised to 1/2 plus 1, 3/2 divided by 3/2 minus 3 times y square over 2 minus antiderivative of y square, y 3 over 3. Okay, now we're going to evaluate this function at the upper limit minus lower limit. Lower limit is 0, so when we plug in 0 0 0, everything will be 0, so no need to worry, just evaluate at upper limit. Pi is outside, 1 raised to any positive power is 1, and 3/2, when we move to the top, it becomes 2/3, so 4 times 2/3, 8/3, minus 1 square is just 1, so 3/2, minus 1/3. That's the answer. Let's simplify. Pi 8/3 minus 1/3, 7/3 minus 3/2. So pi 3 and 2, the common denominator will be 6. 3 goes 6 twice. 2 times 7, 14 minus 3, 9, which is 5/6. So 5/6 pi cubic units.